Hello, and welcome to your third grade weekly preview for math content for the week of October 10th. I'm Sherry Height, and my information will be at the end of this video in case you need to contact me for support or just have questions over the video. Okay, so first off, before we get into this week, I would like to talk to you a little bit about DCP data and how to get the biggest bang for your buck when you're reteaching and spiraling those TEKs back in. So we want to start with thinking about a few things before deciding which TEKs we're going to go after the hardest. So let's start with frequency. You'll notice I have little snippets of the lead forward distribution chart, the frequency distribution chart. And so what you'll notice is for the SC of 3.2a, which is composing and decomposing numbers to 100,000 using objects, pictorial models, and numbers, including expanded notation, has been tested a total of 6 times. Once every year and twice in 2019 on the STAR test. Okay, this is a pretty easy TEK and it's been tested a lot. Okay, now let's look at 3.2b, describe mathematical relationships. You'll notice that this is a supporting TEK and it's only been tested one time at all since 2017. And this is one that is very wordy and not very easy for students to read and grasp understanding of. So when I look at these two TEKs, if I were going to tutor or accelerate or reteach, I would focus more on 3.2a than I would on 3.2b for a few reasons, but one of those reasons being the frequency. Like, there's not a big chance that 3.2b will be even on the STAR test this year, but it's a for sure thing that 3.2a will be, okay? And so that would be a TEK that we would say, okay, possibly that's one I'm gonna go after. Let's look at 3.2c. Again, it's only been tested one time. Now this TEK is represent a number on a number line as being between two consecutive multiples of 10, 100, 1,000, or 10,000, and use words in order to round whole numbers. Now I know as a former third grade teacher, rounding is a killer. It can be a hard TEK for some of our students to grasp. Now, rounding on a number line is not quite as hard as when we look at 3.4b in a moment, but still, it's only been tested one time. It's something that's hard for third graders to grasp, so that's going to be something that I'm probably not going to go after. It's only been tested once. It's not really worth as much time as 3.2a. Notice these are all TEKs that we taught before this last DCP and were on your test, and that's one of the reasons we're looking at them. Let's look at 3.4b. 3.4b is when you round to the nearest 10 or 100 or use compatible numbers to estimate solutions to addition and subtraction or subtraction problems. Okay, so this one is a pretty hard TEK for third graders. I remember back in the day that I would beat my head up against a wall and tutor this sucker all year long. And it would just take forever for students to grasp it. So if I had to do it over again and I was teaching this grade, this third grade, these TEKs, I would not go after this one because I would get a bigger bang for my buck by going after 3.2a. And there's a few reasons why. So frequency is one reason, but let's also talk about time to mastery, and that depends on the standard. So what we're going to do is look at the predictability of questions. Another TEK that was on this test partly, but will also be on DCP2, is 3.4a, and that's adding and subtracting 1 and 2 step problems, right? Okay, so yes, they are word problems. A lot of them are 2-step, that's for sure, but it's tested frequently And a lot of the problems have a predictability. You may have noticed in our very first video, or maybe a little bit later on, we talked about once you add in subtraction, many times it's asked like this, where you have to combine two things and then subtract to find the difference from another. So it's almost always two steps where you have to combine two and then subtract from the total. That is a predictability within that TEK in those questions. So if I were to work on that type of question for, let's say, 2 to 3 weeks until everybody gets that type every time, then I could actually get to mastery on that TEK that has a high frequency and a predictability to it. So that might be a question that I go after in my tutoring or in my reteach or in my spiraling review or my problem of the day, because it's frequent and the time to mastery is going to be pretty good because of the predictability of the questions. Okay, but there's one more thing that we want to look at when we're looking at DCP data and deciding what to spiral in to reteach. And that is, we don't want to go after our low performing TEKs. We do want to go after our underperforming TEKs. Now, to me, at first, this is not how I did data. When I was a teacher, I looked at what was the lowest and I went after that. Well, that actually wasn't a great idea on my part. It seems like as teachers, that's what we mostly do. But as far as getting a bigger bang for our buck, it's not the best thing. So what does that mean? Well, let's say that on TEK 3.4a, the district is at 80%, right? The district is at 80%, and typically on STAR, we're at 80% on 3.4a. But my class, or my grade level at my school, we're only at 65%. That means that it's an underperforming TEK because we're not doing as well as the state or better than the state, and we're not doing as well as our district or better than the district. So it's an underperforming TEK, but it's not one of those 30% TEKs. So let's say there's another TEK like 3.4b, the rounding with addition and subtraction, and let's say that typically on STAR, the state is at 40% and the district is at 38%. And this DCP, I was at 35%. That means it has a high level of difficulty, and it would take me weeks and weeks and weeks and probably months and months before most of my students master that TEK. So I'm not going to go after that TEK because it's not tested frequently. It doesn't have a high predictability, or maybe it does, but it has a high level of difficulty, so I'm not going to go after it. I'm going to go after things that are frequently tested. I'm going to go after things that have a high predictability, but have a low level of difficulty. Why, you might ask? Well, here's the reason. If I continually go after things that have a lower level of difficulty, so they're underperforming, but they're not way low, and they're frequent, and the predictability is in there, then I'm probably going to be able to get many more TEKs to mastery by my students than I would if I go after something with high difficulty that isn't tested very often. And it's tested totally different ways every time it's tested. So we're going to look at the frequency. Are the questions similar in the way that they're asked? And I'll talk more about that when we look at this week's questions as well. And is it a low level of difficulty? Those are the things that we're looking for. Now, once we address those TEKs, there's a few different ways that we can go after them. We can do a whole class mini reteach and then put it in our problem solving every day. For example, if I were going after 3.4a, I would probably put that in my problem solving block because it's 1 and 2 step word problems, right? Maybe not every day because I'm going to spiral things in that are taught on before the next DCP as well. But during my problem solving block, I can continue to spiral those things back in that are frequent, have a good predictability, and don't have a high level of difficulty, okay? So I can do it that way. If it's a skill, like let's say 3.2a, where we're composing and decomposing numbers, that expanded notation teak, I might put that in my Give Me 5 spiraling review. Or if I do Lone Star Math, I might use whichever color goes with that 3.2a every single day, okay? Because those are more skill-based. So I'm not going to put that in my problem-solving block every day. I'm going to put that in my Give Me 5. You'll notice that in the Give Me 5 for 3rd grade, we stop giving you what to put in there after the first DCP. The reason that we do that is because we want you to use your DCP data and your classroom data and put those things in there yourself. For example, if they're struggling with just basic subtraction, put that in there horizontally. See if they can set it up or count it up on a number line every day. And then if they're struggling with telling time on a clock so that when we get to elapsed time, we make sure that they can tell time on a clock, absolutely put that in there. If they're still struggling with counting money because we only spent like a day on it, put that in there. And then put your expanded notation in there as part of your Give Me 5 and work on that teak, because as we know, the DCPs this year have changed. When we get to DCP 2, I'm going to be looking at these same high priority indicators. I'm going to be looking at bang for your buck teaks, and your test is going to have some spiraled teaks from DCP 1 that have a high frequency of being tested, they have a predictability of being tested, and they're a lower level of difficulty. And I'm going to put a few extra questions on DCP 2 so that we can see our students growing. That's what we want. We want students growing. So maybe they didn't do fantastic on 3.4a on DCP 1. If it's on DCP 2, we can see, did the students grow? Same for 3.2a. Did the students grow? Okay, so I'm going to be looking at those things. You're going to be spiraling them in your Give Me 5 or your Lone Star Learning and your problem solving block. Also, when you accelerate, when you tutor, you can throw in some of these things every once in a while to see if your students are growing on those teaks as well. Okay, so those are some ways that you can spiral some things back in so that we can see if we're growing students on the things that we were underperforming on. Okay? If you have any questions about any of this, if you would like me to come out to your campus and look at your DCP data and help you decide which teaks to go after to give you the biggest bang for your buck, and how to do the reteach on those or how to spiral them back in, let me know. Because what we don't want is we don't want you taking 4 days the week after the DCP and going over all of these questions and not going on with your scope and sequence. But what we do want is for you to spiral it back in your problem solving block and in your spiraling review block, okay? Also, Ryan Castle is great at this. So he or I could absolutely come out and help you decide before your DAT chat or during your DAT chat on your campus what teaks to look at and what teaks to go after and how to do that, okay? So if you need help, please reach out to us. We'd love to be your support. All right, so now we can get to the week. So this week is a short week. We have fall break on Monday and Tuesday, yay! And then Friday we have a flex day, and it is either for COGAT or your Florence field trip. I have actually been told that some of you have both of those things in that week. And so if that is the case, you will push the second day of this to the next week until you have another flex day. But if you'll notice, this is a highly tested teak. This is one of those frequently tested teaks. So we definitely want to make sure that we spend a few days on it, especially if our students aren't getting it completely on day one. And so this teak is 3.5e. It is a readiness standard, so it's tested 1 to 2 times every year. and it is apply addition and subtraction to input and output tables. Notice when you read the actual wordage of the TEK, it says represent real-world relationships using number pairs in a table and verbal descriptions. So sometimes it's going to be about the numbers. Sometimes it's going to be about the words, the verbal descriptions from the table. So this has been tested 6 times in 5 years with addition and subtraction input-output tables. It's also been tested with multiplication and division input-output tables. So it's been tested it's been tested more than once every year with an addition subtraction input-output table. Whoa. So that tells us, okay, I am going to make sure and hit this TEK hard and heavy, but I've got to make sure that I relate it to the real world. And so that is what we are going to do. So let's look at first, there are 2 ways that this is typically tested. So remember, when we were talking about DCPs, we were talking about the predictability of the TEK and the frequency of the TEK. Well, here's predictability number 1 for this TEK of 3.5e. There are words in the problem, and you have to choose the table. That's been tested 3 times, and I'm going to show you what that looks like, so no worries. So, each day a bakery makes cookies and muffins. The number of cookies the bakery makes is always 12 more than the number of muffins it makes. Which table shows the relationship between the number of muffins and the number of cookies this bakery makes? Now that's a lot of reading for our 3rd graders, but what we really need to hone in on here is reading to make sense. The number of cookies is always 12 more. So what that tells me is when I come look over here at the number of cookies, it should be more than the number of muffins. That's not more than the number of muffins. That is, and that is. So right away I can tell you this one is not going to be our answer. And it has to be 12 more. So the number of cookies is always 12 more than the number of muffins. We really have to go through this think aloud process with our students. What makes the most sense? Obviously, if the cookies have more, we need to make sure that the table has the cookies having more, right? So we right away know B's not right. Then we know that it's 12 more cookies than muffins, right? So that means if I have 6 muffins, then I should have 6 plus 12 to give me the number of cookies. Well, I know 6 plus 6 gives me 12. See how they use that little distractor though? So that can't be our answer. Oh, I think I went too fast. I have an extra X on there for some reason. But when you get to the bottom of it, on C, 1 plus 11 is 12. So that's 11 more, so that can't be it. But 12 plus 12 is 24. And 24 plus 12 is 36. And so these right here, we have to make sure that it works here and here and here and here, because sometimes it'll work here for addition, but when you go here, it'll be multiplication. So we have to be very careful on that front. Okay, so on this one, a store is having a sale on books. The sale price of each book is $6 less than the regular price. Well, that makes sense, doesn't it? A sale, the price should be less. So we have to have those conversations. Which table shows prices of different books at this store? $6 less. So let's look at this. Why would the sale price be more? That makes no sense. The sale price should be less, so we can automatically get rid of that. Look at this. Well, that's just $2 less, right? This one, oh my goodness. This is 30 and 5. That's not $6 less. That's way less. So I know that can't be right. What about this one? 18 minus 6, does that give me 12? What about 39 minus 33? Oh my goodness, it looks like it works for all of them. Okay, So on this one, this is a different type, and I should have moved it down a little bit, but this one shows a table and then verbal descriptions to match the table. So it almost always asks, based on the relationship shown in the table, which statement is true. So there's kind of that predictability, even though this is kind of a hard type question. So 4 people at a snack bar each bought a drink. The table shows the amount of money each person gave the cashier and the amount of money each person got back in change. Obviously, if they gave this much and they got some change, this number should be less. But how in the world do we figure that out? Sometimes we can come down here and try each one of these and see if it works for all of these. Typically, what I teach the students to do is go 55 minus 3. And somewhere, I think I have that done, but it's not wanting to go to the next slide. There it is. If I do 55 minus 52, I get 3. So if I give 55 and I take away 3, I would get 52 also. So what that tells me is the drink must cost 52 cents. A drink at the snack bar costs 52 cents. Now look at here, a drink at the snack bar costs 52 cents. Oh, they're the same, except for this part. Because the amount given to the cashier minus 52 equals the amount of change. This one, the amount given to the cashier plus 52 equals the amount of change. Does that even make sense? So we have to talk about what's reasonable. These are both 48 cents, so they don't make sense. But if I had come over to the side and written 55 minus 3, I would have gotten 52, and I could have figured out that A was the correct answer. Okay, so here comes the next question. Well, how do we teach this? This seems like a lot, and I don't want to just show my IQ released items, right? So we are going to start off with video games. We're going to start off with bonus points on a test and video games that are on sale. And there's a reason for this. So you'll notice that it says video game sale $3 off the regular price. In the table, in the directions, it says use counters to model the regular price of each video game, then complete the table to find the sale price. So if my regular price is $12, I'm going to put $12, the process, minus $3, because it's $3 off the regular price. And then I'm going to use counters to kind of figure out, well, what would be my sale price then? And so here I've just done a picture of dollars, which you could use plain money, or you could just use red and yellow 2-color counters. It doesn't really matter to represent the dollars. But I put $12 here, and I took $3 off because they're on sale for $3 off the regular price, which means my sale price should be smaller than $12. Have those conversations. So what is my sale price? $9, and I can count my counters. So they will have to use counters or dollar bills and then draw a picture of it, okay? And their pictures can be rectangles or circles. It absolutely doesn't matter. So they're going to go through this process for all of these different amounts because, video games don't cost the same price. So this video game, the regular price was $12. This one, it's $16. This one, it's $19. This one's it's $20. And so they'll go through this process for all of these. Notice this is like one of the IQ released items where it was $6 less than something. Remember that? So this is just like it, but it's more real world for them and using manipulatives so that we can really understand these tables. Now, after they've gone through this, the journal piece is your friend Donella creates her own table to find the sale price of each game. Is she correct or incorrect, and why? That why is really important. So here's what I'm noticing. When I look at the regular price and the sale price, well, I do see a $3 difference, but the sale price is more than the regular price. So is Donella correct? No, because the sale price should be less than the regular price. So these are things that come very easy to us, but we've got to teach our students how to read the tables and correctly and make sure they're reasonable. Okay, so that's one of the activities that you're going to do on that first day. Okay, so here is another way that we can teach it. This problem right here, you see a star. Anytime you see a star, that means it is an IQ release item, or it is just like it with different words and numbers, okay? So and that means don't skip this one, right? What I've done here is I've made it into a drag and drop. Sometimes you have to escape out of the PowerPoint for the students to be able to drag them, but we wanted them to have that practice so that they, because they showed examples like this with tables for drag and drops with our STAR 2.0 item types, okay? So we want to have practice with this. They've kind of given us a hint that this is what it might look like. Ms. Morales gives bonus points when a challenge question on a test is answered correctly. Bonus points. If you get bonus points on a test, is that going to make your grade higher or lower? Why? How do you know? These are questions that we want you asking your students to talk about. The table shows the relationship between test scores before and after Ms. Morales gives the bonus points. And so we really teach them, what do you notice about this table? What do you wonder? Okay, I'm noticing it's about test scores. Here are the test scores. Oh, so we have some C's and some B's. And after the bonus points, we have all B's. That's interesting. So we want our bonus points should obviously be higher. That score with bonus points should be higher than the test score that was original. So this will be a drag and drop to where students will have to either choose plus or minus 2 or 4 to put in those rectangles. But before we do that, here's how we kind of try to teach it. Think, is the score getting bigger or smaller? And then think 77 plus what gives us 81? Well, luckily, this one's really easy because we can just count up on our fingers. We can say 78, 79, 80, 81. That's counting up 4, right? But if it's bigger numbers, we can always take the big number and subtract to find out how many we went up to get here, right? So 77 plus 4 is 81. Is that true for this one? 79, 80, 81, 82, 83. Oh my goodness, it is true. Is it true for the next one? 81 plus 4 is 85? Sure is. 83 plus 4 is 87? Sure is. So I know that I would drag plus here, the test score before bonus points, plus 2 or 4, plus 4 equals the test score after bonus points. I will say that last year on Aware, it won't be like this on STAR, but last year on Aware, some students were putting 4 plus. They were getting them backwards, and Aware was counting it wrong because it didn't make sense in the sentence. And so it won't allow you to put words where the numbers go on STAR, but last year on Aware it did. So have that conversation with your students also, that we've got to read this and make it make sense. The test scores before bonus points 4 plus doesn't make any sense, does it? We've got to make sure this makes sense, okay? So that's just another tip for Aware. All right, so questions. If you have any questions or any concerns, whether it is about DCP data and how to spiral that back in, or if it's about these tables and verbal descriptions, just either send me an email at slheight@mesquiteisd.org or give me a call at extension 28705, and I would be absolutely happy to help. Thank you so much for being here with us and just learning more about data and learning more about the TEKS that are coming up in curriculum. Have a great week.